In this video, we're going to go over single replacement, double replacement, and combustion reactions. We're still going to go through the same steps. We're going to write out the word equation first, then we'll write out formulas, cross our charges. So single replacement, if you'll notice in the generic problem, A and B switch places. So A comes over here and knocks B out of the way and bonds with C. And then B comes over here and stands by itself. One thing to keep in mind when you do single replacement reactions, they have to, whatever's trading places, either have to be both positive or they have to be both negative. I think on your sheets, everything that's trading places are all going to be positives. So if we look at this first example, lead 2 and iron 3 nitrate, lead and iron are both positive. If we look at our Roman numerals, this tells us lead's a +2, iron's a +3, nitrate's a -1. So we know our two positives are going to trade places. So iron is now going to come over here and be by itself, and then lead's going to take the place of iron. So we're just going to write iron 3. And this is going to become lead 2 nitrate. Alright, so now let's write out the formulas. Lead 2, lead is just Pb. We don't have to do anything with that Roman numeral 2. We just needed that in the product side. Plus iron 3 nitrate. So Fe, NO3. Nitrate's a +3, or iron's a +3, nitrate's a -1. So we put nitrate in parentheses and the 3 outside, our yield sign. And we have iron 3. Again, we just needed the 3 so that we could write out iron 3 nitrate. We don't actually write it with iron. And then lead 2 nitrate, Pb, NO3. Lead is a +2, nitrate's a -1, so we cross our charges and we put the 2 outside. And that's all we have to do for that one. The next one, sodium and calcium sulfate. So sodium has a +1 charge, calcium has a +2 charge, sulfate's a -2. So we know that the sodium and calcium are going to trade places. So calcium's going to come over here by itself, and sodium is now going to go and bond with sulfate. So we'll have calcium on its own, and then we'll have sodium sulfate. These are not transition metals, so we don't have to have Roman numerals. So now let's write our formulas. Sodium is just Na. It's not a diatomic, so we don't have to write any numbers with it. Calcium is Ca, sulfate is SO4. There are a +2 and a -2, so they cancel out. Calcium, it's just Ca by itself, it's not a diatomic. And then sodium sulfate, sodium is a +1, sulfate's a -2. So when we cross the charges, it becomes Na2SO4. So that's it for single replacement reactions. Our next type are double replacement reactions. We essentially do the same thing. A is going to come over here and replace C. C is going to come over here and replace A. So we're just trading spots. We have to make sure that positive switch with positive or negative switches with negative. So we have silver sulfate and sodium nitrate. So silver is going to swap with sodium. Sodium is going to swap with silver. So we end up getting sodium sulfate and silver nitrate. Now let's write out formulas. Silver is Ag. It is a transition metal, it's in the middle, but it always has a +1 charge. It will never have a Roman numeral. Sulfate is SO4, and it has a -2 charge, so we should have Ag2. SO4, plus sodium nitrate, NaNO3. Sodium's a +1, nitrate's a -1, so they cancel. Sodium sulfate, NaSO4. Sodium's a +1, sulfate's a -2, so it becomes Na2SO4. And then we have silver nitrate, AgNO3. Ag's a +1, nitrate's a -1, so they cancel out. Right, the next one, sodium iodide and calcium sulfate. Sodium and calcium are both metals. They're both positively charged. So calcium's going to trade with sodium. Sodium's going to trade places with calcium. So we get calcium iodide. And sodium sulfate. Right, so if we write our symbols, sodium is a +1, iodine's a -1, so they cancel. Calcium's a +2, sulfate's a -2, they also cancel. Now products. Calcium is a +2, iodine's a -1, so when we cross it becomes CaI2. And then sodium is Na. Sulfate is SO4. It's a -2 charge, so it becomes Na2SO4. Alright, so that's everything for double replacement. And then lastly, we have combustion. These are really easy. On combustion reactions, we always have some kind of carbon-hydrogen compound. Our number of carbon and our number of hydrogen can change with every problem. But we always add to it oxygen gas. Our products are always carbon dioxide and water. Combustion reactions usually involve some kind of spark, flame, not necessarily an explosion, but something will usually catch on fire during combustion reactions. So in our example, pentane, I wouldn't expect you at this level of chemistry to know what pentane is. It is C5H8. But we know in a combustion reaction for our word problem, pentane and oxygen produces carbon dioxide and water. Same thing happens. You may not know what butane is, but it's a combustion reaction. So we're going to put butane and oxygen produce carbon dioxide and water every single time. There are no exceptions. If you have a carbon compound, it's going to react with oxygen gas and produce carbon dioxide and water. So now if we go back and write formulas for the rest of it. Oxygen, it's a diatomic, O2, produces carbon dioxide, CO2, and H2O. So writing out combustion reactions is extremely easy. What's tricky is trying to balance them. Butane, the prefix but in organic chemistry means 4. So it's C4H6. This is what's usually in lighter fluid. So butane and oxygen, remember it's a diatomic, so it's O2, produces carbon dioxide and water, H2O. All right, so that's all there is to combustion reactions.